All right, so let's look at number 5 from your midterm study guide. You're asked to solve this third degree equation. Notice it's x to the third, so we're looking for a total of 3 solutions. The degree of your polynomial tells you how many solutions you should have, so we should have a total of 3 here. One maybe more obvious solution is -6. -6 cubed plus 216 equals 0. That's the real solution, and we can get that without as much trouble, but to get all of the solutions, the imaginaries plus the real, it requires factoring down a larger polynomial. So in this particular one, we have a pattern. This is the original problem right here, and I've already kind of started it here. The pattern says anytime you have perfect cubes, either an addition or a subtraction of perfect cubes, if you will find the cube roots of each, so the cube roots here would be x cubed's cube root is x, 216 has a cube root of 6. 6 times 6 times 6 is 216, so that's its cube root. So you start with the 2 cube roots, and then you square the first cube root, put it here, that's x squared. You multiply the 2 roots together, 6 times x, 6x, and do the opposite sign, so minus 6x, and then you square this last cube root, makes it 36. So again, anytime you have perfect cubes, and if you see one like this on your test, the perfect cube pattern is the cube roots of each, same sign in the middle, and then square times together with the opposite sign and square. And that helps us factor it down. Now, there's no special pattern to factor it down any further. This quadratic here will not factor again, so it's not factorable. So we then set each factor equal to 0. So we factored as much as can be factored with that method. And then we solve each part. This one we can solve, it's linear, by just throwing the 6 across the line to get that one solution that I mentioned earlier, the -6 real solution. But the other 2 solutions from this quadratic equation. Solve this quadratic, a is 1, b is -6, and 36. And we know we have a formula for undurable quadratics. We can plug that in the quadratic formula with this method. So it says take the opposite of b, which will make it +6. Plus minus the square of b, -6, and the negative being squared as well makes it +36, minus 4 times the a value times the c value, and we put all of that over 2 times the a value. Then we simplify that down as much as possible, and it's always this radical that gives us what type of solution we're going to have. So we want to simplify the radical next. 36 minus 4 times 1 times 36. I'm going to have to get my calculator out for that. So let's do that and see what we've got. So it becomes 36 minus 144. And then 36 minus 144 certainly puts us in the red. We're going to have a negative number there. So that's meaning that we're going to get imaginary solutions in this one, and that's why it wasn't factorable, because we have imaginary solutions. Now the trick here, and this is a lot of the algebra that we do, is trying to make this, clean this up to its best form. So we know that it's imaginary because of the negative, so that makes the I, if you want to go ahead and do that part. But then 108, even though it might not be the most familiar number to us of what its factors are, it will break down. If you think about what goes into 108, and we're looking for perfect squares, like does 4 go into that? Does 9 go into it? 16, 25, 36. So you start knocking that down, saying, does 108, and this is what I would do to be, let me get my phone open, sorry. To show you my method, how I would do that, I would take my calculator out and I would say, okay, 108, does that divide by start large, 36? And I kind of just knew that one. But if I would have started with 4, say the other way, I would have got that to work, but it wouldn't have been the largest perfect square that goes into it. So try to find the largest list and from that. So 108 divided by 9, for example. That works, but 108 divided by 36 will be our best one to come out even. Now notice when it doesn't look like 108 by 25. It comes out as a decimal, so it doesn't divide by 25. But 108 will divide by a lot of these numbers actually, but you want the biggest perfect square there that goes into 108. So it just so happens that 36 times 3 equals 108. Call 108 36 times the square root of 3, because if you multiply that together, you've got the same thing as 108. So what happens is the perfect square part, we can bring that out. That's a 6. So we can bring a 6 out and a 3 left in, and now it's reduced to 6i, 3 left in, over 2. And then one last thing, these will reduce. Actually, you have to pull apart imaginary solutions into the real and the imaginary. So I would say 6 over 2, that's the real part, that's 3, plus and minus, and then I would do this part divided by 2, which is 3i, since 6 divided by 2 is also 3 there. And then you've got the I and the radical 3. And that would be your quadratic solution. So there's actually a total of 3 solutions. If we look back up here, we've got -6. So when you're typing it into your MyLabs, you'll say -6, comma, 3 plus 3i radical 3, comma, then 3 minus, see there's a plus and a minus, 3i radical 3. So there are your 3 those would be 3 complex solutions. They account for all types of solutions. You know, complex includes the real and the imaginary. And that's what you type in for your answer. Hope this helps.